Hello everyone, thanks for joining us today for the October 2016 Ona Report Webinar. The title of today's presentation is Managing Soil Quality for Pasture Sustainability. My name is Maria Silveira and I am Associate Professor in Soil and Water Science here at the University of Florida IFAS Range Cattle Research and Education Center. I also want to mention that at the end of today's presentation there will be time for questions. So you can submit your questions either using the GoToWebinar question panel, or feel free to either call us or email us. I have my cell phone right beside me and I'll be glad to take any questions by email as well. So the first thing I want to share with you is the list of topics that we'll be covering during today's presentation. I'll briefly talk about a little bit of a historical perspective about routine soil testing and how much routine soil testing has evolved. Then I'm going to briefly introduce you to two relatively new concepts in soil science that are soil function and soil health. Then we'll also discuss what are the soil health indicators, how can we measure soil health, and factors that can affect soil health, and the limitations and opportunities for implementing a full soil health framework. And as you probably noticed, I'm using the terms soil health and soil quality interchangeably. For the purpose of today's presentation, they will both mean the same, but I just want to make you aware that depending on how this topic is approached, soil health and soil quality can have different meanings. But let's start by talking a little bit about the history behind soil testing. For the past 50+ years, soil scientists have dedicated considerable amount of time developing this extraction and correlation procedures to determine the nutrient availability in the soil. So the first extraction procedure was developed in the late 1800s. It was a citric acid, and it was intended to extract phosphorus from the soil. And by the way, this was the 1894 citric acid extraction procedure was developed even before the pH scale was developed, so a long time ago. It was really in the 1930s that most of the procedures for extracting water-soluble plant-available phosphorus were developed. In the 40s, most land-grant universities established their extension soil testing labs, and this was in response to a demand because of increased use of fertilizers. So farmers wanted to be able to test their soil so they could make better planning in terms of fertilizer management. And even some of the current methods that we use, for instance, MELC1, it was developed and established in the 50s. So when you look at some of the bulletins, some of these publications, they date back in the 50s. So for a number of years, this has been a very important topic in soil science. Back in the 50s or nowadays, the purpose of soil testing remains the same. The four main objectives are to measure the nutrient availability or the nutrient content in the soil and identify nutrient deficiencies or in some cases excessive nutrient concentration in the soil that can cause a toxic effect on the plant, and also predict crop response to fertilizer application. So with that information, farmers or soil managers can build a nutrient management plan that's relevant to that particular area. One thing I want to point out that when we do routine soil testing, we're not accessing the total nutrient concentration present in the soil. So the soil test is supposed to mimic what the plant sees available. And much more important than the actual concentration of nutrients in the soil is the index, the rating scale. It's probably the most important piece of information in the soil test report, because the index provides a prediction of the relative nutrient supplying capacity of the soil compared to the crop needs. So based on the index, we can determine whether or not additional fertilizer is needed. Another important fact that I want to highlight here is that soil testing only works for non-mobile nutrients, such as phosphorus, potassium, calcium, magnesium, even some of the micronutrients. For highly mobile nutrients such as nitrogen, soil test is not a very good indicator of nutrient availability. So in terms of historic perspective, these pictures are from one of the initial soil testing labs. As you can see, the instrumentation and the extraction and the determination procedure were very basic. It was a much more labor-intensive procedure because each nutrient was extracted separately. The majority of the analysis methods were based on titration, as you can see, so the numbers were not highly accurate. As we transition to more modern world, nowadays the soil test procedures, they need to be easy to perform, they need to be relatively cheap to the producer, and also be adapted to a wide range of soil conditions. So because the commercial labs handle a much larger number of samples, those are the characteristics that are desired for routine soil tests. It's different than if, for instance, we're conducting research. Some of the procedures that we run when we do research are much more labor-intensive, but for the purpose of generating fertilizer recommendations for a large number of samples, these procedures need to be easy and easy to perform and need to be relatively inexpensive. So as we transition from the old methods that extracted and analyzed one element at a time, now we have different procedures and different analytical instrumentation that allows multiple elements to be analyzed at the same time. So for instance, those two pictures on your right-hand corner are instruments that exist in the University of Florida Soil Extension Lab. So with the advance of technology that allowed commercial labs to run a much larger number of samples and a much faster turnaround. So, as I indicated, much more importantly than the actual nutrient concentration in the soil is the interpretation and how they are rated in terms of likelihood of plants responding to additional fertilizer. So, for instance, in this picture, I'm using soil test P as an example. You assume that as soil test P increases, soil P concentration in the soil increases, the yield of particular crop will increase up to a certain point. Usually, when the nutrient levels in the soil are either at medium or higher level, we don't expect to see an increase in crop production as affected by nutrient application. So, if you assume that we get 100% of the maximum yield at high levels, usually between 75% 25% yield reduction will be expected if the nutrient levels are below median. So that's why we complement, we use fertilization to increase that yield potential. However, I'm going to point out two major limitations with the traditional soil testing. One of them is particularly for perennial crops. When we test the soil, we are only looking at the nutrient availability in the top 4 to 6 inches. But perennial crops, like most forages that we grow here in Florida, they have a much deeper root system. So even though we are only analyzing the top 4 inches, the plants can actually use nutrients for much deeper soil depths, so which are not accounted in our traditional soil testing procedure. And the other important factor, the important limitation associated with soil testing is that, as I indicated, soil test is supposed to characterize the chemical composition of the soil. So some of these nutrients, the concentration of macro and micronutrients that are present in the soil. However, there are other chemical, physical, and biological properties that also affect crop production, which are not necessarily accounted when we do our regular soil testing. So many times from the practical standpoint, many times we see, for instance, I'm going to use pastures again because that's the crop that we're most familiar with, that we work on more frequently. We see pastures that are performing well, and we can see the visual differences. And right beside we have pastures that are showing some signs of degradation. And when we look at the soil test reports, the values are basically the same. So this is one of the limitations. Even though it's an important tool, we continue to use it, we encourage producers to use, there are some limitations. So that's why this soil health or soil quality concept was introduced. And I also want to say that this is not something new. It was actually developed in the early 90s. And the main motivation was to respond to increased emphasis on sustainable agriculture. So soil scientists and land use managers were interested in taking a more holistic approach of soil fertility and soil management. So what is the definition? What is soil health? And like I said, for the purpose of today's presentation, I'm using interchangeably, soil quality and soil health interchangeably. According to the USDA and RCS, soil health is defined as the continued capacity of the soil to function. And I'm going to explain what the word function means. To function as a vital living ecosystem that sustains plants, animals, and humans. So in other words, plants, soils can do much more than sustain plants. There's a number of important ecosystem services associated with soils, and they are equally important. So let's move to the next slide. This again is the definition of NRCS. Depending on the source, soil functions are defined differently. But according to NRCS, soil provides 5 essential functions. One is regulating water, or in other words, the cycle of water retains the rain, it prevents flooding. So this is important to both agriculture as well as urban communities. It sustains plant and animal life. Of course, this is a very vital function for agricultural soils. Soils can also act as a filtering, buffering potential pollutants. For instance, they act like a sponge, eliminating, sometimes immobilizing or eliminating pollutants and preventing them from entering, for instance, waterways. Soils are also responsible for the cycling of nutrients. For instance, carbon, nitrogen, phosphorus. They all stored, and they also undergo several transformations in the soil. So those nutrients that are stored in the soil, they're a very important source of nutrients for plant growth. And soils also provide physical stability and support for plants, or it can be human. This is another definition of soil functions according to the Food and Agriculture Organization in the United Nations. So they basically is the same as I presented before, but they break down to more different categories. And as you can see, if you look at some of these soil functions, agricultural soils are involved in almost every single one of them. For instance, provision of food and fiber. So this is obviously something that agricultural soils provide, carbon sequestration, water purification, and so forth. So the concept of soil function was established to acknowledge some of these important services that soil provide that go beyond just the production of food or animal products. So depending on the management goal, so let's say, for instance, in this slide, I'm using plant productivity. That will be the main management goal of agricultural soils. There are different supporting specific soil functions that support these goals. So for instance, the main goal is increasing or maintaining plant productivity. The main supporting soil functions are nutrient cycling, water relations, and physical stability, and resistance and resilience. So depending on the goal could be recycling of organic waste. For instance, if a municipality is using soil as a way to get rid of organic waste, then the desirable or the supporting functions will likely be different. This is another example. Soil can have, depending on the function or the goal that you have, in this the second column you see here is crop production. So agricultural soils, the main goal is crop production. Different soil properties can have a direct or indirect impact on crop production. And like I said, some of these properties are not necessarily, or in fact most of them are not accounted when we do the routine soil test. The routine soil test, when you look at, for instance, what we are doing is we are determining the nutrient availability. But other factors such as texture, which is a physical property of the soil, can also have a direct impact on crop production. But we typically don't analyze soil texture when we do our routine soil testing. The same as with the water holding capacity and so forth. As I explained, in the previous slide, if the main goal is something different other than just plant production, then the properties that will impact that particular soil function will likely be different. This is like the reason why I'm emphasizing the different goals is because the selection of the soil health indicators will be different depending on what the management goal is. So in summary, the soil health encompasses the different interrelated physical, biological, and chemical properties that determine the status of the soil to function or perform that particular function. So there are different soil properties, physical, biological, and chemical properties that are used to determine the health of the soil. And for agricultural soils, specifically, this soil health concept is should be able to support the production of food to a level and quality that's sufficient to maintain the human requirements, but also provide some of these ecosystem services that we were talking about for the maintenance of quality of life for humans and the conservation of biodiversity. So by increasing soil health in agricultural systems can have also indirect positive impact on sustainability, because it can potentially increase plant vigor and yield, can reduce risk of yield losses due to stress, and this is again the word resilience. Soils that are healthier soils have a much greater resilience, or in other words, ability to come back after stress, resist to stress, and there's also potential for reducing input costs. This is particularly true for annual crops when they convert from a conventional system into a non-till system, so there's potential for also saving some money in there. So how do we determine that soil health status of a soil? There are different soil health indicators, and they are much more complex than the routine soil test, as you can tell by just the definition of the concept. But there are some desirable characteristics of these soil health indicators. Again, they need to be easy to measure, because most likely there will be a large number of samples that will be handled. They need to measure specific soil functions, so they need to be something that a soil attribute that's related to a specific soil function. They need to include chemical, biological, and physical properties. Some of them are very difficult to measure, and they need to be accessible to many users and applicable to field conditions. So these are the desirable, in theory, those are the desirable characteristics of a soil health indicator. Oh, I'm sorry, and I forgot to include they need to be sensitive to management and climate variation. So I don't expect you to read every single line in this table, but the take-home message here is, for instance, again, depending on the function or the objective, different soil properties will be related to that specific function. For instance, you have here biological, chemical, and physical properties. Soil respiration is directly related to soil resilience. For instance, soil test P, if the main objective is nutrient cycling, this will be an important soil property to be considered in the soil health assessment. And as you can tell, some of these properties are intrinsic, or in other words, you cannot change the characteristic of the soil. For instance, texture, you don't change soil texture. Soil texture is not affected by management. But some are more, the dynamic soil, what I'm calling dynamic soil properties, are affected by management. And what I'm showing this table, again, I don't expect you to read every single line, but assuming that the management goal here is plant production, as you can see in the left-hand corner of this table, and there are different indicators of soil health, for instance, soil test P, potential mineralizable nitrogen. Some of these properties have different impact on plant production. So depending on the importance of that particular property, that property is given a score. For instance, soil test has the highest score among all the properties that are listed in this table here, score 10. So that means it gives a weight. The greater the influence of that particular soil property on the management goal, in this case plant production, the greater the score. So based on the weighing factor and the actual measured value, some labs come up with this soil quality index. For instance, in this case, it's 80 for this particular soil. And I'm going to explain a couple more slides. I'm going to explain what the limitations are in terms of interpreting that number. So, as you probably are aware, there are a number of commercial labs in the country that are offering this soil health testing. And as I said, there's still some limitations, even though the concept has been developed many years ago. There's still some issues that need to be addressed before we can actually promote this type of approach for producers. There's a lot of information over the internet. Ohio State and Cornell are the two that produce, probably main universities that produce a lot of information on soil quality, soil health testing, and Cornell offers that analysis. NRCS also has quite a bit of literature on soil health. And in terms of services, there's even some field test kits that are being now offered. You can find these over the internet. Whether or not they'll produce a result, whether or not this is useful or not, it's a second story. So, as I said, there's some factors. What are the factors that affect soil health? Some are intrinsic, you cannot change. Depending on the parent material, the climate, some of these soil attributes will not change. And as I indicated, soil texture, the depth of the soil, those are the things that you cannot change. But land management can affect some very important properties that also have positive impact on crop production. For instance, I'm going to use soil carbon as one example. So proper nutrient management and proper grazing management can increase soil carbon. And by increasing soil carbon, there's a number of benefits that can directly or indirectly affect forage performance. I'm going to skip this. So what are the limitations associated with this? It all sounds very nice, but what are the main limitations? First of all, I indicated that there are a number of commercial labs that are offering this test, but as you can probably imagine, there's not a standard procedure. So if you see different labs, they will offer completely different sets of extraction and services. And I think one of the major limitations is still the results interpretation. So if we use one of the soil quality index that was developed for corn in the Midwestern, those soil quality index are probably not applicable to our conditions in Florida. So if you're going to use that for a perennial pasture, the results interpretation is also a major limitation. The third limitation is the high cost. One thing I didn't mention, there are a number of labs, but the cost of this analysis, depending on the package that you should choose, by the way, they offer different packages, it can vary anything from $50 to $200+. So imagine if you follow in University of Florida recommendations, every unit needs to be sampled separately, you end up with a very high cost associated with the soil health assessment. And to me, I think probably the most important factor is the economic factor that may limit the extent to which soil health concept can be adapted at a farm scale. And what I mean by that is some of the management practices that will likely affect soil health may not necessarily have a positive impact on crop production, or might not be economically feasible. So the lack of incentives to adopt some of these management practices is also a major concern. But what are the opportunities? And I'm listing the limitation as being an opportunity. Even though our current economic system only rewards farms for the products that they produce, the agricultural products that they produce, there is a growing recognition that agriculture offers much more than just food. So by documenting these benefits and the critical important ecosystem services offer a potential for the society to recognize farms and land managers for the true value they provide to the society. So in terms of our future research goals, one of my group goal is to develop this soil health framework for Florida pastures. Of course, like I said, the parameters that will be affecting soil health in our pastures will likely be different than those developed in the Midwestern United States. So this framework needs to be developed at a local scale. And hopefully this tool will allow producers to make better decisions in terms of managing their pasture for improved production as well as sustainability. So with that, I'll conclude my presentation, and I'll be happy to take any questions. I'm going to see if I can go back to the... I have my cell phone with me, so you can either email me, that email that's on the screen, mlas@ufl.edu, or you can also use the GoToWebinar question panel. How do I go back to the question panel?
Click the which area.
Do I have to press anything here? Or is it? Okay, well, it looks like we don't have any questions. Well, no, maybe we do have one question.
Just click it there. Oh, it just says Maria. Just
Cheryl, I don't think I got your question, but I'm going to encourage you to please call me or send me an email. I'll be happy. Oh, yeah, 1 second. Do any of these tests monitor bacteria and colloidal fragments? Some do. They don't differentiate bacteria. They do microbial biomass. Some tests offer microbial biomass. And there's also some limitations because microbial biomass includes bacteria and fungus and includes dead organism and as well as active organisms. So yes, they do, but then, again, interpretation is a major limitation. And the other thing with some of these biological properties, they change a lot. They are affected by season, time of the year, temperature. So the interpretation is a major limitation. I'm going to have to stop now. I'll be happy to take any further questions. Like I said, call me or email me. And I want to thank everyone for attending today's seminar. Be sure to watch the upcoming November Ona Report webinar that will be offered by Dr. Felipe Moriel. And the title of his presentation will be Recent Nutritional Strategies to Enhance Reproductive Performance of Heifers, a summary of range cattle REC studies. And this webinar will be held on November 28th. Also, don't forget our upcoming field day next week on the 27th. If you haven't registered yet, I think the deadline for registration is the 25th. We'll be happy to see you all here next week. Thank you so much.